I'd like to do a very short video here on creating waveforms to apply to the inputs of digital logic gates or ICs on a breadboard. And we're going to do that in the Waveform software. And it's the pattern generator. That's the one that creates digital signals. There is another generator, a waveform generator, that creates analog signals, but the pattern generator is going to be the one that we want. I have my 82 hooked up. I'm going to select the pattern generator, and up comes the screen. Now we're going to do simple things and then we're going to advance on, but this should be a good reference for you. So if I want to create two signals to put on the input of like a 2-input OR gate, for example, I'm going to click Add, and you can create a signal, but if you want those signals to be related, like I want to have binary counters, and a truth table is two signals in counting order, and that's called a binary counter, the circuit that generates that. So if I want to do that, I have to create a bus because I'm creating the two inputs as a group of related signals. So I select bus, I come down here, I select or click on DI0, and I hold the shift key down. The shift key select is a Windows standard to select two things, and I click Add. And you'll notice I get these two signals up here. One says LSB and one says MSB. So at this point I've just selected the two signals that I want my waveforms to go out of the 82 on. First thing we do working with TTL ICs is we always come here to change the output to PP, which is push-pull. And for the most part we'll always be doing that. The second thing that we do is we can select the type of signal for our group. And right now it has a constant and it's a 0 value, and you can see the output waveforms are 0 for those. We want to change that, so we're going to pull this down, and we said that we would do a binary counter waveform. And when I do that, I'm going to leave the frequency at 1 kilohertz because I think that's a good frequency to work with signals on a breadboard with. And you can see the waveforms that the patterns software in Waveforms created for us are 0, 0, 0, 1, 1, 0, which is 2, and 1, 1, which is 3, and they start all over again. That's a binary counter circuit, and it's a very convenient set of waveforms to apply to the input of a 2-input OR or AND gate because it exercises every single combination. And that's one of the purposes for doing this video. We've completed binary counter waveforms to apply to circuits. Now, I'm going to get by the way, I have to click Run for these to go to the outputs of the circuit, and you can stop that anytime you want. Some students forget to click Run. You'll notice that the pattern tab changes to red and green. If you don't have these patterns running to the output, nothing's going to happen. So you want to do that. So I'm going to close this again. Or I'm going to close the pattern part again, and I'm going to open it up once again. And well, let's just delete these. I expected them to go away, but they didn't go away. So I'm going to select this. And I'm going to delete this waveform, right? So I right click while I'm putting my cursor right in this name and click remove. I right click in here and I click remove. Now, for instance, say that we have a 3-input AND gate and we want to create a custom set of signals. And once again, we're going to show you this quickly so that you can review it. You'll probably understand it a little bit more in the future, but this is a video that you can come back to reference to see how to do this. So the signals are once again going to be related. If I want to put them in time phase relationship, I have to create them as a bus so that I can edit the signals all at one time. If I create them as individual signals, I can only edit one at a time, and that's not going to get me where I want. So I select bus again. I said I wanted to do 3 signals this time, so I'm going to use 0, 1, and 2. I select 0, I hold the shift key down, and I left click on DIO2, and I click add, and it adds all three. Once again, the output type, I have to come here and choose push-pull. Always have to do that. And this time down in my list, instead of selecting binary counter, I'm going to select custom. And I'm going to leave this at 1 kilohertz, and you'll notice that nothing happened over here. That's because a separate screen has to come up to allow us to edit signals. So you see this little, looks like a pencil maybe, to the left of the output type. I'm going to click that. And up comes the custom window. And now we can create our signals down here. So you see here is an area shaded for the second signal, the first signal, and or the first signal and the middle signal. And this is a pretty cool interface. All I have to do, if you look and watch my cursor, I'm not touching anything, I'm just letting it rest over an area. Notice it changes to a 1. No, it's a little small. But if I left click and I drag while that's a 1, I'll click off of that, you'll notice it created a signal. And I can do that down here, and I can do that down here and drag it for the distance that I want, and I click off of there so that you can see them a little bit better. And if, say, you wanted to make a change here, you wanted to make part of this as 0, I just rest my cursor in the low portion of the waveform, and I drag over as far as I want, and I leave that go, and you'll notice it created a 0. Now, one other thing that was a little quirky, actually, it was a addition that we asked them, a change to the software to make, and that was if I want to start two signals at exactly the same time, it was hard to do. You could never get it exactly there because this is representing very small time. So they made an addition to the interface, and if you see, this is the area for the second, first, and the 0 signal. If I put my cursor way up here at the top on the bus, notice it still does the 1 and 0 thing. So if I drag 1 across here, you'll notice that it created signals that start at the exact same time, which is impossible to do any other way, and it's there. But say I only wanted those for the number 2 signal and the number 1 signal, I could come right back to, number 2 and number 0. I could come back to the number 1 signal, get to 0 there, and erase that, and still end up with these 2 signals that line up. And I can switch, customize these signals however I want. There might be times where I tell you to apply a set of custom signals to the input of a gate and show me how they work. That might mean you have to come in here and estimate, the signals that I'm showing you, and draw a set of the signals that transition at the same time as all the signals that you're going to create as the ones that I give you in a drawing. So that's how you create a custom signal. If I click close, you'll notice your custom signals end up here. And like we did before, if I click the run button, that means that it's starting to send those out on the pins of your Analog Discovery 2, which makes these output pins. And you can apply them to the input of in this case, a 3-input AND gate, like we said, and that will exercise your chip in this way. You can use the logic analyzer, look at all the inputs and the outputs to make sure that your chip is operating correctly. That's just a quick introduction. It's meant to be separate on how to create waveforms, how to create custom waveforms. There's also other different types of waveforms you can see in here, and we'll talk about those different things as we go along. So I hope that was helpful. You can watch this video over and over, and in case you ever get in a bind, you should be able to figure out how to get yourself out of trouble. Thanks a lot. Talk to you later.